All right. So the main thing we got into last time was talking about absolute values and how they kind of act in equations. So just to see if you guys remember what we did a good week ago. Take a second or several seconds and solve that.
That's 10-2, right?
Yeah, section 10-2. Yeah. Please don't tell me you think that says 12x minus 11, right? I'm trying to make it clear. On a test, it'll be a little easier. You better thank God I don't actually handwrite my tests. Right? Back in the day, I remember we had these things called ditto machines. That the instructor would write the test, and then you put it on a ditto machine and do like this, and all the copies would come out, and if you smelled it, you'd get a little high. But that was my job. It had no lasting effects at all. But what is it about absolute values in equations that it has to happen, or inequalities? What does it tell me is going to happen?
Switch the sign?
Okay, good. It's going to lead to two cases. Good. So there's always got to be two cases somehow. So one case, what would one case here be? Yeah, one case is if this number in here is already 11, then of course the absolute value is 11. So that's kind of like the trivial answer. If that thing, whatever number this is, if it is 11, then obviously the absolute value of 11 is 11. But what else could this thing be? Negative 11. Because if this is negative 11, the absolute value of negative 11 is still 11. That's why there's two outcomes. There's two things I can put in here. I can replace 2x minus 1 with 11. I can replace it with negative 1. No matter how much I say it, though, I always have several people that do the test and they just ignore the absolute value sign or something and they only do one case. There's got to be two cases with this. Right? And now I get these two little easy equations to solve, right? How do I solve it? Yeah. Add 1, divide by 2, you get 6. Yeah, add 1, you get negative 10. Divide by 2, you get negative 5. Sweet. Alright, maybe. Does that sound familiar? Alright. It doesn't if you weren't here last time, but there it is. And of course, the thing that makes this equation easy is the absolute value is already by itself. The absolute biggest mistake I see with these is if I give you something like this. Let's see. All right. This would lead to two mistakes, possibly. Yes, sir.
You have to do the value by itself, right? So you add.
I love it. But two mistakes, the mistakes I get are either somebody would say there's no solution, and you can it's kind of nice in one way but bad in the other, because they'll think the absolute value can be negative, but that's not what this says. This is the absolute value minus 3. That could totally be a negative 1, right? Or the other thing is they give me the two cases, and they make one case negative 1, and the other case all this equals positive 1. Yay! But that doesn't make any sense unless they get the absolute value by itself, right? Always isolate the thing where your x is stuck. So, of course, the first thing I want to do, add 3, 11. So you must isolate the absolute value first before you can write your two cases. Because now I can see what could the inside be. It could either be 2. I couldn't see it up here as easily. But now I can see this could be 2 or this could be negative 2. So that's my two cases. This could be 2 or it could be negative 2. And then you just got to solve those little, dinky little equations. All right? How we doing? You all right? Yes, sir.
Now, I wasn't here last time, but you don't have to change the inside of the absolute value?
You can't. You can't. And that's actually part of the reason why solving equations, of course, is always difficult, because we're trying to do things backwards. If I knew what this number was, if it was negative, I could change its sign and so forth. But I don't have a clue what 4x minus 3 is. Now, the thing I can definitely not do, and another big mistake I talked about last time, is I'll see people that tell me, okay, 4x plus 3 equals 2, and then they solve it. Now, where would that come from? Is that wrong, or does somebody think that's okay? And you're like, why are you doing this hard way, Jeff? You do it the easy way. There it is. What's wrong with that? Why did somebody do this?
I did that because I thought absolute value was plus or minus.
So you did this year, though.
I did.
What you're thinking about doing, I didn't mean to make anybody feel bad. You didn't have to call yourself out. But the one thing what you could do is, one thing you're allowed to do is you could say that either that's the positive or it's the negative of this equals 2. That's what's right. Because then if I divide by negative, I get exactly the two cases I'm talking about. Right? So you could say that the absolute value of x is x or negative x. Do you guys remember us talking about that? So the absolute value of this is either this or negative this. And if I divide by a negative, I get exactly the two cases that I normally start with. Right? So that's a whole other way to teach this. I prefer this way because it actually makes something a little easier here very soon. Right? But I don't know. If you like doing it that way, that's great. But you can't just change just that sign. What's the absolute value of negative 8? 8. Even if I write this as, what you got, Jeff? You can do it, Jeff. Let's say 10 minus 18. Isn't that the same thing? But that's not 10 plus 18, is it? Because that would be 28. This answer is supposed to be 8. Right? So the answer to this is 8. I don't care what I do to negative 8. I can't suddenly change the answer. And this would change... it wouldn't change the sign of the number, it would change a part of the number. It left 10 alone and it changed 18. You're not allowed to, you either change the number or you don't. Right? So this mistake here was a part of the number would have changed if it was 4x plus 3. A part of the number changed, not the whole number. Alright, so your way would work, you just have to be careful, put the negative on the whole thing. And then it would distribute, you can go from there. Cool. All right. Okay. And of course, we didn't finish this out, but add 3, divide by 4. Got it. Add 3, divide by 4. Cool. I like it. All right. So let's get back. I think the last thing we did, I did one example of the inequalities. And that was the stay close to me, or the sandwich, right? And I'll show you something. The way you look at it actually, well, we'll see. I'll show you how it makes some more sense out of one thing we're going to do with inequalities. So last time we looked at, and this is still section 10.2, believe it or not. So if we had something like 2x plus 5 less than or equal to 6. So this is the distance. I want the distance to be less than or equal to 6. So I desperately tried to get you guys to understand how I could rewrite this. So if I'm in the middle, how far do I want this to get away from me? I want it to go up at most to where? If I wanted to get no more than 6 away from me, how far up could it go? Away from 6, and how far down could it go? So that would be what? If I'm going down, that would be negative 6, right? So that's why I can immediately write this as that. Because less than leads to a sandwich. I got my bread, and my stuff in the middle. Right? Meat, jam, jelly, butter, whatever you like. But coming off of what you were saying earlier, I want to show you where this really comes from, right? So this is how you can immediately write it, because then I can just start solving this directly. Let me show you where these two cases really come from. One case is I leave it alone, just like before, right? If that number is already smaller than 6, then the absolute value is going to be smaller to a point, right? And remember, what's the absolute value do to something? It either leaves it alone or it changes the sign, right? I'm going to let you soak that in for a second. So the absolute value of x is x or negative x. So what's the absolute value of 2x plus 5? 2x plus 5 or negative 2x plus 5? No. Stay with me. You can totally do this if you want to. I want to show you where this came from, really. Last time we showed this in a few different ways. This time I'm going to show you this way. If I divide both of these sides by negative 1, what happens?
Negatives cancel.
Negatives cancel. What else happens? Sign flips. It flips, Jeff. And that is?
Negative 6.
Good. So this says this is greater than or equal to negative 6, right? Now, can you read it this way for me? That says negative 6 is less than or equal to 2x plus 5, which is what this says, isn't it?
So you have to break it down into 2?
You don't have to.
Okay.
So that says negative 6 is less than or equal to 2x plus 5, doesn't it? Right there. And also it says 2x plus 5 is less than or equal to 6. So this has both cases in it. That expression has both cases in it. So if it's a less than, if it's an absolute value less than something, you can rewrite it immediately like this. That is caught between the positive this and the negative this. Because that would be what the two cases would be. And again, the idea, I don't want this to get more than 6 away from me. So it can go 6 up or negative 6 down. So that's exactly what this says.
What happens if that always kind of really fix?
If it's a less than. If it's a greater than, that's what I call the restraining order situation. So we've got to figure out why the hell I say that. So we'll talk about that in a minute. So you can solve. How do you solve this triple-sided monster?
Add or subtract?
Yeah, subtract 5 from where?
Both sides.
All 3 sides. Cool. All right, because now there's an inside, a left side, and a right side. All right. And what do you get here?
Negative 11.
All right. And then you
Divided by 2.
divide by 2. Cool. So the old thing about do whatever to both sides is actually a specific example. You do things to all sides because you might have 3 sides. So I get my answer's got to be between negative 11 halves and 1 half. Now let me investigate this one other way, because I think I kind of hinted at this last time, but I didn't go all the way into it. Look back. This is saying the absolute value. What is 2x plus 5? I don't know. Right? So it's the absolute value of something has got to be less than or equal to 6. I really want you to understand that's absolute values, right? It's not 11. Somebody's going to go, 11 is less than 6? Who is this guy? Can you give me some numbers that would make that work if I plugged it in there? Just think about what numbers could I put in. So could I put an 8 in there? Would that work? No, because absolute value of 8 is 8. That's not less than 6. So what number would work? 5 totally would work, right? What else?
Anything?
4, 3, 2. What's like the lowest number you can think of that would work? Would negative 6 work? Totally. What's the absolute value of negative 6? Is that less than or equal to 6? Would negative 7 work? What's the absolute value? If you try to plug a negative 7 in, what's the absolute value of negative 7? 7. Is that less than or equal to 6? No. So do you see how and so I can't put an 8 in. I can put all the way up to 6 in. Bam. Or I can put all the way down to negative 6 in. Bam. I mean, that's what this is saying. This number can be anything up to 6, because the minute it's over 6, 7 is not less than 6. And the minute it's under -6, it doesn't work either. So it can only be in between there. That's why I call this is distance less than something. Stay close to me. Sandwich. Stay close to me. Contained, right? That's a less than. It's all about being contained. If I were to graph this, what would it look like? Oh, shit. If I graph this thing, what would it look like? Oh, shit. I shade in between what numbers? -11/2 and 1/2, right? And what's going to be on both of those? Brackets. Kick ass, because I'm allowed to, it's equal to it, right? There you go, sandwich. That looks a lot more like, well, you know, if you really, really use your imagination. But there's the bread, and a lot of, and for some reason they put the meat like that. All right, maybe. Does that sort of make sense? I really want that to make sense as to why this is the one that looks like this.
Wait, when you graph it, what do you put it on the keyboard?
Say again?
When you graph it, you're number 2. Like, you know, like, for example, 0's in the middle, and then it descends and descends to -3 top. So you don't need numbers. Oh, you don't need numbers?
I'm sorry. What?
You're saying
like a scale?
You're saying where those fractions go inside of numbers, but you don't.
Yeah, like on a scale. Like
Oh!
1/2, like
I don't care about that shit.
Oh, it doesn't matter.
If you don't know where 1 is in relation to 1/2, I can't really help you at this level, right? So I'll just get straight to the point.
Okay.
So I mean, if you want to put a scale down, then that's fine, right? -11/2 is just beyond -5, right? If you want to do that, that's fine. I'm telling you, you don't have to. Right? That's Math 88 stuff. I'm not going to make you do that. If you can't do it, that's bad. But I won't know. What would this look like in interval notation?
-11.
With, amazingly enough, because you already know it, right? Use the same symbol on the graph as you do in the interval notation. Cool. I like it. All right. You guys look enthralled. All right. So what about the other situation? What about this weird-ass restraining order I keep talking about? So what's the basic idea of a restraining order? So hopefully, you don't have to bring it up. I'm not asking if you've ever had to do this, right? But what's the idea behind a restraining order? You say, yeah, you have to be at least this far away from me, right? So if I lived in a one-dimensional world, you with me? I live on a number line. And I'm right here, and I've got a restraining order in somebody that says you can't come closer than 5 feet away from me. That's a really weird restraining order. Just don't throw a lawn dart at me or something. So here I am, right? And let's say I'm standing at 1. So how close can somebody get up here?
6 feet.
Yeah, 6, right? 2, 3, 4, 5, 6. You can do it, Jeff. So they could be they can't get closer, so they could be there or up. Does that make sense? If they come closer, then the judge, I can go get the judge and say, hey, judge, he's coming over here. Right? And then how close can you get down here?
-6. No, -5. 4.
Yeah, so what was this? You got to be further than 5 away from me, right? And actually it would be with 1. So this restraining order says, I'm standing at 1, you got to be at least 5 feet away from me. Right? So if I'm at 1, you could be at 6 and just stare at me. He's looking at me. Or you could be 0, 1, 2, 3, 4. You could be down here. You can get that close to me on that side. You guys get that idea? So that's going to be 2 separate things. That's why I keep doing this. Stay the hell away from me. The distance has got to be more than or at least something. Don't be close to me. It's not a haunted house. I don't like you. Get away from me. Right? You guys are going to take it personally. So how does the algebra work with this one? Well, hopefully you understand I can't write it like this then. It's not sandwiched. It's not like this. It's like this. There's 2 separate statements. I have to make separate statements, and they actually kind of jive exactly with the cases from equations. So if I have, let's try to do this problem. Okay, Jeff. So one case would be like it always is. One case is everything's the same. If this is already bigger than 5, then it works. So if that number is already bigger than 5, it works. That's case 1. Now, using the thing from earlier, or it's the opposite of that. And when I divide by a negative, what happens to this inequality?
Turned into a positive.
So one case is everything's the same, or that is less than or equal to negative 5. If I change that sign, I'm going to flip that sign. So why didn't it happen with an equation? Because when I switch an equal sign, it looks the same. So just real quick, we'll do another one after this. If I add 1, I get x greater than or equal to 6, like we got there. If I subtract, add 1 again, I got x less than or equal to negative 4, like I got there. Let's try another one. Here, I got an idea. Solving these things shouldn't be the problem. Understanding the first step normally is the problem, right? Solving that was easy. Once I understood how to rewrite it, right? So a little rapid fire kind of thing here. So if I had 2 is just the number of the day. If I had this less than, how could I rewrite that first off? It's less than. Stay close to it.
-4 less than.
Yeah,
2x
so
plus 7.
when you see the less than, if you do this, you go, okay, -4 to 4. That's the idea. So from -4, yeah, there, from -4 to 4, that's where that could be. Stay close to me. Don't go any further than -4 that way or 4 that way. Stay close to me. Because it's less than, distance less than. And then you solve. And solving that should be the easy part. What about if it was 5 minus 4x greater than 2? So now it's greater than, so then you go, stay the hell away from it. So you need 2 separate statements. They're not connected, they're separate. So what's one statement I can make?
Negative 2 is greater than 5 minus 4.
The first case is always,
Negative.
you leave it alone. So the first case is always that. So if that number is already bigger than 2, the absolute value will be bigger than 2. Do you see that? 5 minus 4x is some number. I don't know what it is. But if that number is bigger than 2, the absolute value will be bigger than 2. Or, what's the other case? Like that, you put a -2, or just like we did earlier with the equations, but what has to happen to the sign now, because it did a negative thing? It's got to switch. So it was greater than, so now it's got to be less than. So when it's less than, it's nice. You can write it nice and compact like this. And to be honest, if you really wanted to, get in trouble doing this. But just in case any of you guys were taught a different way with this, you could do this problem. You could do it in 2 cases the same way. One case is it's the same, right? One case is it's the same. And the other case is you switch the sign and you switch the sign. But I really want you to see, there's 2x plus 7 less than 4. There's 2x plus 7 greater than -4. It's here already, right? I've got both cases here. So this kind of captures the idea physically. Don't get very far away from me. Go there and there, but stay closer to me than that, right? And that, of course, is just the math 2 cases of the inequality. All right, so let's try some problems all the way out. Let me get some fresh problems. Let's try this one all the way out. Greater than or equal to 4, sure. So it's greater than. So what can you do, like if you wanted to, in the air? What would you do? What kind of motion would you make? Greater than. I want the distance to be greater than something. That means I want somebody to stay close to me or stay the hell away from me. Yeah, I want you to stay that. No, it's greater than. The distance, I want it to be greater than something. So you can't be 3 feet. You got to stay the hell away from it, right?
So 4x plus 1, that's the same.
So
like
you can say
4
4x plus 1
is greater than 4.
is greater equal to 4? Or
Or 4x plus 1 is less than negative 4. Or
less than or equal to negative 4? Yeah. Okay, so it kind of, hopefully it makes sense. When you change that, when you make that negative, the inequality's got to flip also, right? And then you solve those. So if I solve these, what do I get? Subtract 1. Divide by 4. Or subtract 1. Divide by 4. When you go to graph this, you only give me one graph. It's not going to be connected, I know, but only give me one graph. Don't graph that and then graph that. Give me one graph. It's got to be greater than or equal to 3/4 or less than or equal to negative 5/4. Now, I like the point that somebody brought up earlier about I don't really care about scale too much. So I'm being very nice to you. So please, dear God, get them on the right side of each other. I really hate it when somebody gives me the negative 5/4 up there. You know, I mean, come on. Let me be nice, but you got to, meet me halfway. Which way am I going to shade from the 3/4? Which way does that say to shade? Yeah, it's an arrow pointing that way, so I shade up. Let that be nice. That's an arrow. So from 3/4, I want to shade up. Right? Greater than 3/4. And what symbol do I want to put on the 3/4? Bracket. And from negative 5/4, I want to shade down. Good. Bracket down. Does that match up with the idea of restraining or stay the hell away from me? Now, here I am in the middle. You better stay the hell away from me. So if it's greater than, it should end up looking like this. If it's less than, it should end up looking like a sandwich contained. Yes, sir?
How do you write that interval?
Good. So what's the lowest it could be?
Negative 5/4.
No. That's the highest this part could be. What's the lowest it could be?
Infinity.
What kind of infinity?
Negative.
Negative infinity all the way up to...
3/4. No. Positive infinity.
Negative
No. Does it include this area in the middle?
3/4.
No. So where do I stop?
Positive.
Negative 5/4.
Really?
Totally. Because do I include any of this? No. Where do I shade? Where's shaded? Where's not shaded? Here. So can this be in my answer? No. Because I shade where the answer is, right?
So you say 3/4.
So visually there's two separate things. Interval notation, there will be two separate things that go together. So see how that looks the same? And this shading represents this. Please, again, don't do this. Because that's freaking me out. Right? Because I'm like, what the hell's that then? Shit! No. So you can't find infinity on the number line. Does that make sense? If you found infinity, what's one step further? Buzz Lightyear, I don't know what the hell it is. Or from
3/4.
3/4
To infinity.
to infinity.
There
Good.
you go. So,
I like it.
so you put both of those up there.
You got to.
Okay.
Yeah.
So,
And you can put a little or in the middle, or if you want, there's a symbol for that mathematically. This is the symbol for or. The little U is the symbol for or. It's like you or you. Somebody. There's or right there. You. Or you put the word or. I don't care. They both mean the same damn thing. So it just depends on what language. You want English or you want math? All right. So let's try another one, and then I'm going to give you guys a couple to try on your own. All right. Let's see. That's a little too evil. Let's see. So what do I have to do first here?
Add 2 to the 8.
So I heard subtract is right.
Subtract the 2.
Good. Subtract. Because what's the operation?
Addition.
Addition of a positive 2. So I got to subtract 2 to get rid of it, right?
Okay.
Division won't help me out here. Subtract 2. So you're good. x minus 5 greater than 6. So you got to isolate your absolute value first before any of what we've said is applicable.
So 3x minus 5 is greater than 6, and 3x minus 5
Yeah, so you got 3x minus 5
less than negative 6.
greater than 6, or
3x minus 5 is less than negative 6.
less than negative 11. So in one case it's all the same. Right. And again, I really want this to be more than just you're just following these steps. Why does it make sense? Because if this number, whatever that number is, if that number is already bigger than 6, then of course the absolute value is bigger than 6. And what's the absolute value? Let's see if I can make this part to make sense. If that number is less than negative 6, give me a number that's less than negative 6. Negative 7, that's crazy. What's the absolute value of negative 7? Is that bigger than 6? Yes. That's why that makes sense. If you're big positive or big negative, the absolute value will make you bigger than 6 in the end, right? So if you're bigger than 6 already, or if you're less than negative 6, the absolute value will make you bigger than 6 in the end. Awesome. So then you just solve. So I mean, the first step is the hardest step, is to realize what situation you're in. But once you've got your 2 cases broken out, you just solve them each. Don't let that part be the hard part. This is the easy part. So how do I solve? Add 5. Divide by 3.
11 thirds. And then
Cool.
negative 1 third.
And then add 5. I like it. Divide by 1.
So answer is negative 30, column negative 1 third.
So let's see here. Wait a minute.
Okay, so
Yeah, so negative 1/3 is there. 11 thirds is up there. I want to go which way from 11 thirds?
To the right.
Yeah, graders. And what symbol do I want on the 11 thirds? Parentheses. I like it. And then the negative 1/3, I want to go below that. Parentheses. And now we've seen how this kind of thing works. It goes from negative infinity up to negative 1/3. Skip all this mess. Start over again at 11 thirds and go forever. So see, this is the middle. This middle part is skipped. That's not part of the answer. So from negative 1/3 to 11 thirds, not part of the answer. Okay. All right. So here's a couple for you to try on your own.
Because this was up
Good. Yeah.
but if it was going in
That would just be between these two. So that's a nicer situation, right? It's not, there's a ceiling and a floor. Does that make sense? So when it's contained, there's a ceiling and a floor. Here, it's like forever down, bottomless pit, and then forever up. Holy crap, that's why it's weird. Right? The other one is kind of nice, it's contained. Yeah, so then I do a single set, a single interval for the answer, yeah. Here, these are 2 separate intervals. Oh.
It's negative. So you like to split them up, and it works too. Yep.
All right, so let me catch up with you guys.
Sorry.
What is that?
That's Kefka from Final Fantasy 6.
Oh, of course. I mean, took the call. That's ballsy. All right. All right. These things happen. So what situation is the third one? What situation is this one?
Which those two is greater than or less than equal to 10.
All right. What situation? Should I expect the answer to be contained, or should I expect the answer to be separate? Separate, because greater than. I want you to stay the hell away from me, right? You see that greater than, and the absolute value is by itself, right? You can't make any judgments until you get the absolute value by itself. But now it's greater than, so that's a stay away from me. All right. So I can write one case is going to be what?
Right, the same one.
Exactly. So if that number is already bigger than 10, it'll work.
And less than
Or?
or equal to negative 10.
Yeah, good. Changes sign, changes sign. So the next big mistake is people just forget to change the sign on the second dude, and then it gets all weird. And now solving these should be pretty simple, right? Subtract 2, it's 8. Divide by 4, you get
This equals
2.
to
Subtract 2 is negative 12. Divide by 4, it's negative 3. And of course, I'm going to ask you to graph the answer and then interval notation it. So here's your negative 3, here's your 2. You knew from the beginning what it was going to look like. So you're not going to make a mistake and do like this. You know it's supposed to be stay the hell away from me. What symbol's going to go in each bracket? And see how they face the way it's going to shade. And what's the interval notation going to look like?
Negative infinity,
Yeah.
comma, negative 3.
Negative infinity up to negative 3. Same symbol.
2,
Or
2,
2 to infinity. Kick ass. Good?
Yeah, that's good. Is that parentheses or brackets or the next to column? Or is that ones?
Here?
Yeah.
Oh yeah, that's a 1. So I try to make my absolute value.
Oh, I thought they were brackets.
It gets freaky.
Yeah.
So what's the first thing I got to do here? Beautiful. Get the absolute value by itself. So add 1. So they get 3x minus 1. Absolute value less than 2. So this is a situation where with the distance to be less than something, I want somebody to stay near me. So I know the answer should be like this. I should be able to write it in one statement because it's all contained, right? So the 3x minus 1 can go up to 2 or down to negative 2. Another big mistake is when people try to write this like that, and that don't make no damn sense. I want you to understand why. If you try to write this like that, it would come out like negative 10, greater equal to 4x plus 2, greater equal to 10, right? See how this says negative 10 is bigger than 10? Do you see that? Don't write that, because it's bad. Right? Gets me worried about you. Negative 10 is not bigger than 10. Okay, cool. And now this should be the easy part. All right, solve this. I
plus 1 to this.
add 1 everywhere.
Not subtract. Oh no, we already did that. Excuse me.
Divide by 3.
Divide by 3. So I get negative 1/3 is less than x is less than 1. So then graphing this is nice. Negative 1/3 Up to 1, but what symbol do I want on both of those?
Parentheses.
Good, parentheses, I don't want to include it. Alright, put the jelly in there. If you don't like the sandwich idea, whatever, it's
Or
fine.
you add or you divide by all three sides.
How do I cancel minus 1?
Plus one.
Beautiful. So if I add 1 and negative 2, it's negative 1. Add 1 to 2, it's 3.
Oh,
and then
you
divide by 3, yeah.
Yeah.
The last thing I do is divide by 3, cool. And then interval notation for these are easy. Right? Yeah, negative 1/3 to 1. Done. See, that's nice. That sandwich is nice. Okay, so what's kind of cool is the next section really shows you why we like looking at absolute value situations. Because for one thing, I like to know where my safe zones are. And what do I mean by that? Well, we're about to get into this this idea of shading stuff in, but in 2 dimensions. Right? So X, Y plane. I like that. Someone's rolling their eyes already. So remind me, if we step out of the absolute value thing for a little bit, let me overanalyze this for a second. Right? And you're all like, you do that really well, Jeff, so go for it. What's the most important point for me to put on that number line?
3.
Because why?
Because you don't know what X is.
It's the division between answers and not answers, right? Good and evil. Answers and not answers. And, of course, which side am I going to shade?
Right.
Because does 4 work in there?
Yes.
4 is bigger than 3, but what about 2? 2 is not bigger than 3, right? So either they all work on one side or they all don't work. So I'm really overanalyzing this, I know, for a reason. So 3 is the dividing point between answers and not answers. And then I just shade the right side. Okay. Amazing. So now, if I have 2 dimensions, scheisse. If I have something like this, now what this is saying is, where are all the y's smaller than this line? So now I'm going to have 2 dimensions. So in 1 dimension, I can cut it in half with a point. 2 dimensions, how would I cut 2 dimensions in half? Chop with a...
There.
What would cut 2 dimensions in half? I would draw a line. Thank you. So this is the line that divides answers from not answers. Right? On one answer I'm going to shade, on one side I'm going to shade, on the other side I'm not. So how do I graph that line? Yeah, I know the y-intercept is -3. Yeah, -3, and then it tells me to go up 2 over 1. Would it be included or not?
Yes.
So all the points on the line work. Sort of like this was not included. So I don't want to include, because 3 doesn't work. But if this would have been like this, then I would have included 3. You guys with me? So I'm going to shade one side or the other. I don't know if the dividing point or the dividing line is an answer until I see this. And I go, oh, good, the dividing line is an answer. So what I do 2-dimensionally, I can't put a giant parenthesis on it because then it won't be straight. A line straight. So it's either solid or dotted. And that kind of matches the old open circle versus shaded in circle, right? So in this case, it's going to be a solid line. Right? You can make sound effects if you want to. And then there's 2 ways to get the final answer. Let me give you the textbook method first, and then I'll give you my method. Right? So by the textbook, you use what's called a test point.
So 0, 0.
Right? Exactly. So remember, the whole idea is either this side is all the answers, or this side is the answers. The same way it was up here. So if I pick one point, and if I can, I'm going to pick the point 0, 0, because that's the easiest numbers to plug in. So if the point 0, 0 works in here, I'm going to shade it in that direction, because if that works, everything on this side works. But if it doesn't work, then that side's the answer. So when I plug a 0, 0 in, so the test point is 0, 0, is 0 less than or equal to 2 times 0,
minus 3. Is 0 less than negative 3?
No.
No. No. So then can I shade in this direction?
No.
No, because it didn't work. So none of these work, so I shade the other. Okay, maybe.
Wait.
So watch, what does that mean? What does that mean about this point, for example? What does that mean about that point? What point is that?
0. I mean 3, 0.
What does that mean about that point?
If you plug it in, it's
If
gonna
you
be
plug it
true.
in, it's supposed to
Be true.
be true, because it's on the side that's shaded, right? So when I plug in 3, 0, is 0 less than or equal to 2 times 3 minus 3? Is 0 less than or equal to 6 minus 3? Is 0 less than 3?
Yes.
Yes. So, and what about that point? If I plug that point in, what would happen? It would not work. All right. Maybe. And the physical application that this leads to, right? Very often what we use this for, we use multiple lines and we graph them all. So you can imagine, I'm not going to give you a whole big ugly problem. But if I graph one line and shade, and then I graph another line and shade, then I'll figure out where's my safe place. So if I'm there, maybe I'm building a building. So if I set things up so it's here, something's going to fall and kill somebody. It's bad, right? Or if I'm here, something else bad is going to happen. Or this could be like very often I think of this like an electrical situation, where this would be not enough power, so nothing happens, and this would be too much power, so something blows up. So if I graph my restrictions, I go, oh, this is my safe area. If I turn the power on, I want to make sure that I'm somewhere in here, or else something bad or not enough good will happen. Does that sort of make sense? This is what this leads to. And this idea of constraints is used all the damn time. Yes, sir?
Can you do a problem?
Yes, in fact, yes, because that's like the next level
Okay.
of this whole thing. Before I do that, let me make sure you guys are cool with this basic idea. You guys do exactly what we did here. So this is the answer to this. This is the only way to answer this. Because how many answers are on the line? Infinite. And then, holy shit, you're adding in all these. There's like an infinity of infinities of answers. Holy crap. So the only way to answer this is visually. You're not going to list the answers. Holy crap. You can't even list all these. And then these are like even more infinity than this. Holy what? All right. It's weird. So you guys try this one. And then we'll do one with two of them.
If you want to do that like that.
Yep. So use the same process we used there. So obviously, some of you guys I'm sure were like, oh God, I thought we were past graphing, but we never will be, right, ever. So deal with that part first. But you really should be able to identify the y-intercept, and you should be able to use the slope to find another point. I mean, that's the skill you should have. So what is the y-intercept?
-5.
-5. And then I want to go 4 over 1. So 1, 2, 3, 4 over 1. and it's going to be solid, right? If that wasn't there, it would just be dotted, and that's like an open circle, meaning the points on the line wouldn't work. But the points on this line do work. Pretend like it's straight. Screw. Oh, and I forgot to show you, the way I would do this, so that's the textbook method, it's the test point. But look what this says. This says I want the y's that are smaller than the ones on this line. So if I look at this point, where are the y's smaller? Down, so I shade down. Less than, I shade down. Greater than, I shade up. But the steeper it gets, the less up and down you see, the more left and right. So that's why it gets a little confusing. So you can always use a test point to make sure you're looking at it correctly. So if I use a test point, what's the only time I could not use 0, 0?
The line's going through it.
If the line goes through it, you have to use something that's on one side or the other. And then you just use 1, 0 or 0, 1. Something with a 0 in it, it's good. You can use any damn thing you want to, really, but it's good. So the test point, we use 0, 0. So if I use the test point, is 0 greater than or equal to 4 times 0 minus 5? Is 0 bigger than or equal to negative 5?
Yes.
Yes. Which means I can shade towards 0, 0. Good. Which some of you guys correctly identify as up. It's very steep, but it's still up from that line.
You just plug in 0 for
Plug in 0, 0. Because remember, either all the points, all the points on one side work. So if I found one point that worked, they all work on that side. If I found a point that didn't work, none of them work on that side. That's why I only have to use one point to see what it does. I like it. It's my
Finally
favorite
understand it. Last
phrase.
semester I couldn't get it. I don't know why. Maybe I was busy in class. I don't remember.
I don't know. I can't remember if I went to class.
Thank God.
So if the statement is true, it goes on
That side. I love
If the
it.
statement is false.
It goes
On
on
the other side. Cool. So no matter what point you use, if I would have used that point, it would have come out false. I don't shade in where that point is, I shade on the other side. Right? It's like Giants fans and Jets fans or something. I don't know. Or not. You guys are like, what sport is that, Joe? I don't watch sports. Okay. Or Celtics fans and Lakers fans. Alright, so let's do an example with 2. And the only thing with 2 is
You have 2 lines.
you do one and then you do the other one on top of it. So it's not. So once you know how to do one of them, you know how to do 2 of them. Or 4 of them. Or whatever craziness. Right? So if I said graph the solution, the problem is now of course I've been nice so far, but let's see, it's nothing major to do this. You can do it, Jeff. Sure. Oh, what you got? What you got? Sure. See how that works out. So, of course, what do I need to do first that I didn't have to do before?
Isolate the y.
Yeah, the y by itself, so I can see the slope and the y-intercept. So how do you get y by itself here? Just subtract 2x, so you get y less than negative 2x plus 3, so I can see what the slope and the y-intercept are. And well, for this guy, I'll take the 3x away. See how I force it in there, right? So it's in the right place, mx plus b. And then, of course, I have to, it drives me a little crazy when people stop here and they say, that's the slope and that's the y. I'm like, no, you don't have y by itself. So divide by negative 2. Now, several things happen, right?
Sign switches.
Signs change. The sign here flips. This is
Positive.
+3 halves. -4, kick ass. Well, that's a lot of shit happening there. All right. And then it's really important that you completely graph one before you graph the other one, because you start to forget which line is which when you go to test point. So I'm going to graph this one all the way, shade it, and then I'm going to graph that one all the way, shade it, and then the answer is going to be where the shadings overlap. So how do I solve a system of equations graphically? I graph the lines, and the answer is where they meet. So now that I'm shading, the answer is where the shadings meet. And then what I do is just make that part darker. So if you're one of my anal retentive students, I love you. So if you want to use colored pencils,
feel free. Right? I would hate me in my class because I am horrible. I can't write worth shit. Right? Which is amazing. I still have a job. Not enough students have complained. Mr. Wall, I can't understand what damn thing he's writing. Or saying. So I want to graph that first dude. What's the y-intercept for him? 3. And then the slope tells me to go where?
Down 2 over 1.
Good. Down 2 over 1. And what kind of line is it going to be?
Dash.
Good. Dash, dotted, however you want to say it. Not solid. It's just like putting an open circle. It's the same exact idea. Or putting a parenthesis. Represent that is not included. Let's see if you guys can handle which way would I shade?
Down.
Yeah. Or if you put a 0, 0, and is 0 less than 0 plus 3? Is 0 less than 3? Yes. So then you would shade in the direction of that. Now, one thing you could do, if you don't want like crazy amounts of shading, you could just put like a couple of arrows. And then you can shade at the very end. So you don't have like all this mess all over your paper. Right? And it helps me out too. What about this guy? What's the y-intercept?
-4.
-4.
Up 2 over 2.
Good. Up 1, 2, 3 over 2. What kind of line is it going to be? Solid. Oh yeah, last semester somebody said, if you see a line, you make a line, right? So I see a line, I'm going to make a line. I didn't see a line, I'm going to make a dot, series of dots. Whatever works. And again, if I use a test point, 0, 0, is 0 bigger than 0 minus 4? Is 0 bigger than -4?
Yes.
Yes. Or I just shade up. So where's the answer going to be?
Right there. In the middle.
You guys see how I broke it into 4 parts? And the one part of those 4 where they both work is right here. So then I come on top of that and I... So that tells me danger, 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 safe. Right, for example. Not too bad, right?
No.
As long as you know how to graph a line and plug points in. It's really, really all it takes to do this. I think I assigned like 2 problems that actually give you more than 2 of these. But then you just, if they gave you another one, you just graph that one on top of there. So it's really neat is you sometimes can end up with little triangles of answers, right? And that really matches real life better. Because that's your little area of safety, right? You're going to blow up here, you're going to get poisoned over there, and some bad thing's going to happen over there, and you stay in here, right? Okay. Like it. So that was section 10.3. Inequalities in 2 variables.
Oh wait, that's in 3?
Yep. One special case. How do you graph this line? How would you graph that line?
No, wait, like this.
Yeah, it's a vertical line. I like it at 3, right? So it looked like that. So what if I said this?
Dot.
No. It's still got an equal sign there, right? Shade down. So I graph the line of 3, and then I shade down. So if it would have been y less than or equal to 3, it would have been a horizontal line, and then shade down for that. Does that make sense? I mean, don't try to force that to work like these. Those are special cases that are actually easier. Okay, cool. All right. So, last little thing I want to talk about today. Well, I'll give you a little preview and then we'll head out. Just a tiny bit early. So everybody got this here?
Yeah.
All right. So a little preview of where we're headed. So we know how to solve recall. We know how to solve something like this.
answer. Just made it by numbers. We know how to solve that, right? How would you solve that? What's the most direct way to solve that?
Elimination.
Yeah, you could solve for y, but it's like, already, you see how it's really... So you would take the first one and you would multiply by 2, and then you can eliminate, right? All right, and that's nice, because the minute you do that, how many letters are left in the result? 1, and then you can solve for it. What sucks about both of these is there's too many freaking letters. The number of letters in each is too damn high, right? So what we're doing now, that's old stuff. That's old news. Now in section 11.1, holy shit. This is where we start doing stuff like...
Oh, I hate that.
Alright, good. That's the response I was expecting. I'm not happy about it, but I'll work on it. Really, now think about this. That's relatively simple now, right? This has got like one layer of complexity on top of that. So what happens is, there's 2 steps I've got to do. Here, there was really just one step. Eliminate a y, and then I can solve for x. Now here, if I eliminated like between these two, see if I add these together, don't the z's go away? But then I'm left with x and y still, right? So the whole idea is if I eliminate z again somewhere else, I'll have 2 equations with x and y, and I know exactly what to do then. So we'll get into this next time. I just want to lay this thought in your brain. If I kill a z once, I actually have to kill it twice, because then I'll get 2 equations. So if I add 1 and 3, what do I get when I add 1 and 3? Don't tell me 4. What do you want to add 1 and 3?
5x
5x.
plus 6y.
And the z's we cancel, right?
7.
7. Now if I multiplied this one by 5 and added it to this one, I'll get something else with x and y in it, right? Whatever the hell, I don't want to waste your time. Could I then, between these 2, kill a y or kill an x?
Yes.
So that you kill a variable once, but then you have to kill it again. You have to do what you have to do here double time, because you have one more freaking layer of stuff. One more equation, one more variable. You do the same thing we did before, but you have to do it twice now, because there's more shit in there. So you don't just kill z once, you kill z twice. And then you can kill them here, and you can kill y or x. It's called divide and conquer.
So when you get to that part, you could first kill the x and then kill the y?
Well, you can kill the x, and once you know x, you can plug it back in to figure out what y is. And once you know x and y, you can plug it back in to figure out what z is. And that's what I call dominoes.
That's what I would do.
Yeah. Anyway, so that's obviously not my complete lecture on that. Just a little teaser. You know, like, now I'm going to test you on it now. All right.